On May 16, 2025, Colonel David Levin pilots his F-15I Ra'am fighter, callsign Sword 11, leading two formations breaking into Yemeni airspace at 24,000 feet. The jets are running dark. MCON alpha condition means there are no radar emissions and radar silence except for mission-critical communications. Intelligence has confirmed these ports are receiving Iranian weapons shipments destined for attacks on Israel and international shipping. This means this isn't just another strike mission, it's about protecting their loved ones back home. The desert coastline of western Yemen rises on the horizon. Visibility isn't great. Coastal humidity creates a light haze that extends about 15 kilometers. Levin's targeting display shows the preloaded coordinates for berths 3 and 7 at Hodeidah port, where satellite imagery has detected unusual activity over the past 3 days. Temperature signatures from these warehouses don't match their surroundings, a telltale sign that something is not as it should be. At 1544 hours, Sword 11 descends to optimal weapons release altitude. The internal navigation system counts down to the launch point, 87 seconds and closing. This strike package is flying completely on internal systems. No GPS signals that could be jammed, no radar emissions that would give away their position. The F-15s maintain precise spacing between aircraft, each jet positioned to maximum coverage of the target area, while minimizing the chance of detection. This is when the squadron's thousands of hours of training pays off. The F-15I Ra'am these pilots are flying is Israel's customized strike variant of the F-15E Strike Eagle, optimized for deep penetration missions like this one. Looking at the aircraft's wings and fuselage, there are 11 hardpoints capable of supporting a total payload exceeding 23,000 pounds. Its twin Pratt & Whitney engines push the aircraft to over Mach 2.5, giving it the speed and range needed to strike targets across the region with minimal warning. At 1545 hours, Sword 11 visually acquires Hodeidah Port superstructures, twin cranes rising more than 100 meters above the western dock. The targeting system overlays precision aim points on the crew's displays, highlighting a row of warehouses. Levin's breathing quickens slightly as the weapons officer activates the master arm. All systems are now hot and ready to fire. There's no going back now. The aircraft banks slightly to port, bringing the fuel storage tanks beneath the targeting reticle. At precisely 15:46:27, the first missile drops from the rail. The F-15 lightens instantly as the 340-kilogram munition clears the pylon. 4 seconds later, the formation splits, each jet banking hard in opposite directions. Rampage missiles streak toward the coastline, leaving thin vapor trails against the clear sky. The F-15I's range and low-level flight capabilities allowed the Israeli package to approach the Yemeni coast without radar detection, preserving the critical element of surprise. Without this platform's 1,600-kilometer unrefueled combat radius, the IDF would have needed to launch from much closer, risking early detection by Houthi air defenses. But the mission is far from over. And that is where this pod comes into play. At 1547 hours, Sword 11 activates the Lightning Pod's wide field search mode. The central display instantly transforms, overlaying thermal imagery of Hodeidah port in striking detail. Despite the hazy conditions, the pod's multispectral enhancement features cut through the coastal humidity like it isn't even there. The FLIR system automatically adjusts gain settings to optimize contrast between the ambient desert temperature and the heat signatures coming from port infrastructure. Hodeidah's facilities appear in crystal clear detail, cargo loaders moving between buildings, and, most importantly, 2 warehouse structures showing unusual heat signatures. One building in particular stands out. Its surface temperature is almost 4 degrees Celsius higher than surrounding structures, despite identical sun exposure. That's not normal for a standard warehouse, and the crew knows they are right on target. The targeting system immediately locks onto this anomaly, highlighting it for attack. The warehouse matches intelligence assessments of a suspected weapons cache, but visual confirmation would be better than just a heat signature. Then, as if on cue, the pod's cameras detect a box truck backing into the western loading bay. The Lightning's thermal sensors pick up the temperature difference between the truck's cargo area and exterior, a pattern consistent with the hot metal of munitions holding heat much more than their surroundings. That seals it, they've found their primary target. The Rafael Lightning III-5 targeting pod the pilot is using now is Israel's most advanced electro-optical sensor suite for precision air-to-ground strikes. Mounted on the starboard intake station of the F-15I, it combines forward-looking infrared, CCD TV, and a dual-mode laser designator in a single housing. The entire system weighs about 200 kilograms and provides targeting capabilities that would have required multiple specialized aircraft in previous generations. But with this installed, the F-15I is an all-in-one package. At 15:48 hours, the Lightning pod begins laser designation of the warehouse, emitting coded pulses that bounce off the target at precise intervals. The system automatically compensates for the F-15's movement, keeping the laser spot within 15 centimeters of the aim point despite the aircraft's movement during flight. The Popeye missile's seeker head picks up these reflections, confirming lock with a 97% probability of hit. The weapons officer confirms the solution, and Levin orders weapons free. The missile drops off the rails, followed by main engine ignition less than a second later. The Lightning pod immediately switches to battle damage assessment mode, widening its field of view to capture the entire target area. Impact is nearly instantaneous. The warehouse roof temperature spikes to over 1200 degrees Celsius as the warhead penetrates. Multiple secondary explosions followed at 2-second intervals, confirming what they had suspected all along: this was a major weapons cache. The Lightning pod's auto track and laser designation enabled precision strikes on dual targets while maintaining radio silence. Without it, pilots would have relied on GPS-only coordinates, useless against mobile convoys or rapidly changing situations. In this case, visual confirmation of a moving truck at the suspected weapons cache transformed a speculative strike into a verified hit. But while electro-optical guidance handled known targets, the team still needed to locate buried or radar-shielded threats, and that's where they'd have to break MCON to use their primary radar. At 15:48 hours, Captain Sarah Navin in Sword 1-4 banks towards Salif port for the second phase of the operation. But there's a problem. Meteorological sensors detect a thick cloud formation directly over the target area, obscuring almost 90% of the port facilities. The Lightning pod's thermal imager can barely penetrate this level of moisture. Passive sensors won't cut it, they need to go active. This is a critical decision point. Going active means breaking MCON, potentially alerting Houthi air defense networks to their presence. But without radar, they can't see the target. Navin weighs the options: abort the strike or accept the increased risk. The mission is too important to abort. She makes the call. Going active, she announces, activating the AN/APG-70 radar system. The powerful sensor switches from terrain following to synthetic aperture mode. After a brief warm-up sequence, the radar begins mapping the ground below, penetrating the cloud cover that blocked visual sensors. The aircraft is now emitting signals that enemy systems could detect, but its sidelobe suppression technology minimizes the chance of detection at this range. It's a calculated risk, but one worth taking. The cockpit display renders a detailed radar map of Salif Port. Storage tanks appear as distinctive circular formations, while berth structures show up as elongated rectangles, extending from the coastline. The SAR imagery builds with remarkable clarity despite the weather conditions and altitude. The radar analysis system highlights something unusual: a structure northwest of the main jetty. Analysis indicates reinforced concrete with steel elements is much thicker than normal commercial construction. The structure's radar return characteristics match those of a hardened bunker or buried fuel storage. This is exactly what they're looking for: critical infrastructure concealed from satellite observation. It's the perfect target for the Rampage missile's penetrating warhead. The AN/APG-70 radar integrated into the F-15I is a long-range, multi-mode fire control system designed to support both air-to-air and air-to-ground operations. Located behind the distinctive nose cone radome, the system features a mechanically scanned array operating across multiple frequency bands. Looking at the antenna assembly, you'll notice its ability to tilt in both azimuth and elevation, providing exceptional target coverage regardless of the aircraft's position relative to the ground. This flexibility allows pilots to maintain optimal flight profiles while still mapping and targeting ground structures with remarkable precision. At 15:49:13, the radar detects an electronic emission at bearing 085, characteristics matching Houthi coastal defense radar. Signal analysis shows it's approximately 28 kilometers away, outside effective targeting range of known Houthi air defense systems. Still, this is a reminder that they need to move quickly. The APG-70 automatically calculates optimal release time and altitude and transfers targeting data to the Rampage missile system. The weapon's status indicator confirms missile readiness. With all the data loaded, only one thing is left to do. At 15:49:42, the Rampage missile releases from the pylon and drops clear of the airframe. Navin immediately banks away, already planning her exit route. The radar has done its job, providing targeting through weather conditions that would have blinded optical systems. Without this capability, the strike would have aborted or hit less valuable targets. Now the missile is on its way to the hardened facility, and its terminal phase is about to begin. At 15:49 hours, Captain Navin watches as the Rampage missile's solid-fuel rocket motor ignites, quickly accelerating the weapon to nearly 300 meters per second. This isn't some ordinary bomb. It's a supersonic hunter with one purpose: penetrating hardened targets. Its carbon fiber body glows hot as it pushes through the sound barrier. The missile's fins constantly adjust for crosswinds, ensuring it stays locked on the programmed flight path despite the turbulent coastal air currents. The missile follows a precisely choreographed sequence: boost to get up to speed, cruise to cover distance, descent to prepare for the attack run, and then the terminal phase, where it makes its final approach. Its navigation system maintains pinpoint accuracy throughout the flight, even as it pulls over 7 Gs during its final maneuvers. For the last phase, it drops to just 30 meters above ground, too low and fast for most air defense systems to track effectively. Waypoint data shows the missile passing checkpoint Alpha right on schedule, maintaining a speed of over 620 knots. The missile hugs the terrain as it approaches, its radar altimeter constantly updating ground clearance to keep it just high enough to avoid terrain but low enough to evade detection. This isn't just a dumb bomb, it's a precision instrument performing a carefully orchestrated attack. And the Houthis never see it coming. At 15:50:24, satellite sensors detect an enormous thermal bloom at the target coordinates. The missile has found its mark. The heat signature pattern shows successful penetration before detonation, exactly as designed. Secondary explosions follow in rapid succession as stored fuel or munitions cook off inside the structure. The underground facility that the Houthis thought was safely concealed is now a raging inferno. The Rampage this jet just fired is a supersonic air-to-surface standoff missile derived from the Israeli extra artillery rocket, modified for aircraft launch. Looking at the weapon mounted under the F-15I's wing, you'll notice its distinctive tail section and compact nose assembly housing the guidance electronics. The missile is 4.7 meters long and weighs approximately 570 kilograms, including a 150 kilogram penetration warhead capable of defeating nearly 2 meters of reinforced concrete. It's specifically designed to take out high-value infrastructure that enemies try to protect with hardening and concealment. While this is going on, back at Hodeidah, a second Rampage missile launches from Sword 2-1 targeting Berth 3's crane foundation. The missile accelerates to Mach 1.5 during terminal phase as it dives toward the target. The weapon's hardened steel nose cone punches through steel reinforcement like it's cardboard, creating an entry hole before the delayed action fuse triggers for maximum effect. The warhead detonates inside the structure, creating massive overpressure within the confined space. The blast wave rips through connected underground areas, triggering a chain reaction as secondary explosive materials ignite. The resulting pressure wave causes catastrophic structural failure across a wide radius, completely destroying the reinforced connection between the dock and the crane foundation. What took months to build is eliminated in less than a second. Satellite imagery later confirms the complete devastation at both targeted facilities. At Salif, the underground fuel storage facility heats up to over 800 degrees Celsius in less than a minute, as petroleum products burn uncontrollably. At Hodeidah, Berth 3 is completely knocked out along more than 60 meters of reinforced dock facilities. Rampage missiles gave the Israeli pilots the ability to target hardened facilities from a safe distance, without exposing themselves to air defenses. Without this standoff capability, they would have needed to deliver bombs directly over the target, putting aircraft and crews at risk. But the operation isn't complete yet. They still have one more surprise left for the Houthis. At 15:52 hours, Lieutenant Colonel Avi Stern holds Sword 1-3 steady at 18,000 feet, maintaining data link connectivity with his recently launched Popeye missile. This isn't just fire and forget technology. It's a pilot-guided weapon that requires constant control until impact. The Popeye transmits real-time video feedback to the cockpit at broadcast quality, giving stern a missile's eye view of the approach to the target. It's like flying a remotely piloted aircraft directly into the target. The tactical display shows live footage from the missile's nose camera as it streaks toward Hodeidah's southern dock at over 400 knots. Stern's thumb makes minute adjustments on the control stick, sending commands through the encrypted data link. The missile responds instantly, its control surfaces adjusting to follow his guidance. This level of precision is what separates the Popeye from other standoff weapons. It combines human decision-making with missile speed and power. Range markers tick down rapidly on the display. 500 meters, 450 meters, the target grows larger with each passing second. A transformer station adjacent to the crane foundation. This isn't just any power node, it's the central hub supplying electricity to the entire port's cargo handling systems. Take this out, and the port becomes useless, regardless of what other structures survive. It's the perfect strategic target for a precision strike. Stern fine-tunes the approach path as the missile closes in, ensuring optimal impact angle for maximum effect. The data link maintains rock-solid connectivity despite the distance, with military-grade encryption preventing any interference or hijacking attempts. At 200 meters from the target, the laser rangefinder confirms final distance measurements, and the missile's fuse system updates for optimal detonation. This is precision warfare at its most advanced. Target visual, rolling in. The Popeye missile, also known as the Havenap, is a long-range air-to-surface missile used by the Israeli Air Force for precision strikes against fortified targets. Looking at the weapon mounted on the F-15I's centerline station, you'll notice its cylindrical body measuring 5.4 meters in length with distinctive mid-body control surfaces. Weighing 1,360 kilograms with a 340 kilogram blast fragmentation warhead, it combines substantial explosive power with surgical accuracy. Unlike fire-and-forget weapons, it maintains a video data link with the launching aircraft, allowing real-time control all the way to impact. At 15:52:38, Popeye slams into the transformer station with pinpoint accuracy, less than half a meter from the designated aim point. The warhead punches through the reinforced concrete outer wall before detonating, creating a devastating pressure wave that tears through the facility's interior. Critical high-voltage connections sever instantly, triggering catastrophic electrical failures throughout the network. The explosion creates an overpressure wave so powerful that sensors on the F-15I detect it despite being miles away and thousands of feet above the impact point. The Lightning Pod's cameras capture the complete destruction of the power distribution center, with transformer oil burning at nearly 1,000 degrees Celsius and quickly spreading to adjacent structures. Without electrical power, the port's cranes, loading equipment, and security systems are completely disabled. From another aircraft, a final Popeye missile launches, targeting Salif's main jetty. This one aims for the fuel distribution point where pipeline systems meet the loading berth. The missile guides perfectly to within less than a meter of the designated aim point, a reinforced concrete housing containing flow control valves and pumping equipment essential for port operations. The impact triggers immediate structural failure of the jetty's fuel handling systems, rupturing pressurized lines containing thousands of gallons of fuel. The resulting fire spreads rapidly, consuming approximately 80 gallons of fuel per second and generating a thermal signature visible to satellites orbiting hundreds of kilometers overhead. The flames quickly engulfed adjacent storage facilities, ensuring that both ports would require months of reconstruction before they could function again. Bye for now.